Okay, important thing when figuring out restrictions for a composite function is always remember that a restriction on the inside is always a restriction on the composite function. So again, the restriction on the inside function is always a restriction on the composite function. Then there might still be more restrictions, but you always got to start there. So what we're going to look at here is g of f of x, and I'm just going to kind of play with it so we can explain this idea of why the restriction stays the same. So the restriction on f of x is just that x cannot equal -1 because it's 1 over x plus 1. And the same thing, restriction on g of x is x cannot equal 0. And that's because both of these is you don't want them to be not defined. What I was always taught to remember is that you can't stand on a ball, and that's like saying you can't have a 0 in the denominator. So that's why these are both undefined. So now we're just going to look at g of f of x. Okay, so I'm just going to work out what g of f of x is and then look at the restrictions on whatever the resulting function is. So g of f of x, I'm just putting f of x into g of x, so it's f of x to the -1, which is 1 over f of x, which equals 1 over 1 over x plus 1. Invert and multiply, and you end up with just x plus 1. So g of f of x is just a linear function, x plus 1, which has no restrictions on it. So what we're going to do now is I want to see what happens when those non-permissible values for f of x and g of x get subbed in to g of f of x, if we try and solve those the way we would have before. So if I want to find g of f of -1, technically we're supposed to find f of -1 first, and then whatever you get, you sub in. So f of -1 is 1 over -1 plus 1, which is 1 over 0, which does not exist. So then that means g of f of -1 is g of does not exist, which does not exist. So this x cannot equal -1 restriction on the f of x is still a restriction on g of f of x. Now, the x cannot equal 0, the restriction on g of x, if we plug that in, I get g of f of 0. So to find g of f of 0, I need to find f of 0 first. So f of 0 is going to be 1 over 0 plus 1, which is just 1 over 1, which equals 1. And now we can sub that in. So this is going to be g of f of 0 is g of 1, which is 1 to the power of -1, which 1 to any power is just 1. So g of f of 0, perfectly fine. Because we get a value for it, it's not a does not exist. It's just that x cannot equal -1 is still a problem. So basically, again, what you have to remember is that a restriction on the inside function is always a restriction on your composite function. So when looking at it again, so this is just trying to say that that x cannot equal -1 is our restriction on the composite. X equals 0 is perfectly fine. So we don't really care about the restrictions on the outside function, which is g in this case. It's the whatever's on the inside of those brackets. Those restrictions are going to carry through.